Okay, welcome back. We're talking about the password age function. So this can set the minimum and maximum, which is something that's maximum is easier to understand. The minimum is so that you don't try to reuse an existing password. You can also set up warnings where how many days in advance do you get a warning that your password is about to expire? That would be kind of cool. Okay. So yes, there is the possibility that you would have group passwords. In order, before you can use a group, it's going to prompt you for a password. I have never seen one of those in my entire life, and if you run across one of those, you need to sit down and say, we need to fix this, because that's just wrong. So I hope you never run across one of those. And then, of course, root password, fix it so you don't log in as root. The sudo is so much better because it can limit the commands that you can do. It has all this logging. It's really, really cool. So what about remote use? I mean, you could set up a configuration where you allowed root, but not through a terminal scenario, not remotely, not you sitting at your desk and the servers in the server room. You might allow root, but only if you're physically there at the console. So there is a way you configure it so that the only place root is allowed is at the single console, and then all the rest of the users have to use sudo. That's a possibility. They talk about security power tools on page 996. Nmap. Nmap is a fantastic program. Now, in the Linux world, this has been around a while, but in the Windows world, there's another project called Nmap. It's nmap.org. These guys. Let me hop on over to nmap.org. Okay, so this is a piece of software that will allow you to scour the network and find all the devices that are in there. Pretty cool. It's a network port scanner. Okay, just saying. Nessus is a commercial product. It is very powerful. It has 20 or 30,000 plugins to look at every single. It'll look at all the services. It knows about the Apache 2 service. It knows about the SMB service. It knows about all these things. So when it scans the network, it also looks into a little bit deeper. This guy just says, "Yep, you got a machine there. Good." Metasploit does penetration testing. Remember, if ever you want to do penetration testing, if your company has told you need to do penetration testing, great, that's fine. But you need to document the heck out of this. Because if somebody comes running in there with the security guards in place, you need to be able to say, whoa, 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 I was asked to do this. Okay, just saying. There's one called Lynis, Lynis, basically for doing security auditing. John the Ripper will actually zip through all your password file and go, this one's dumb. This one's too short. This one is duplicate, that kind of stuff. There's one called Bro and Snort. Now, I've used Snort in a laboratory environment. And Snort basically kind of sort of is a network intrusion detection system. You set this guy up to listen for packets that don't belong. Conversations over a network that ought not be there, that kind of stuff. Failed ban is one of those things where you can set it up so that automatically, if somebody has repeated attempts to log into a particular account, you would drop that connection or you would disable the account. You'd do something. So automatically, you don't have the administrator doesn't have to get involved. It's kind of cool. So the next section is a cryptographic primer. So all about cryptography, and I'm going to hit the highlights only. Okay. So just a quick summary. So first of all, we got the CIA triad, right? We got the whole concept of this guy being, confidentiality, making sure the bad guys can't see it. Integrity, make sure nobody mess with it. And availability means the good guys can see it. Okay, that's kind of the important thing. There's a difference between symmetric and asymmetric. Symmetric encryption means I use one key to lock the door and the very same key to unlock the door. Asymmetric means I have two keys. I use a blue key to either lock the door or unlock it. And then I use the red key to do the opposite. Okay, so it doesn't really matter which one I'm doing. If I do lock, I can only unlock with the other. If I do unlock, I can only lock with the other. So it just takes two to tango. Okay, and so if I'm sending a message, it basically looks like this. If I want to send you, if I encrypt with your public key, and then send it across, and then Bob can use his private key to decrypt it. That's how this whole thing works. So this would be the way to sign something. So public key infrastructure, PKI, is a technique that I would use to go get your public key so I can use it to sign a message. Now, inside most emailing scenarios, this is all automatic. You don't have to manually go to the PKI and get Bob's certificate and pull it down and use Bob's certificate to be able to create a, you don't have to do all that. You just say, hey man, I'd like to encrypt this, and the machine does the rest. Okay. It's kind of sort of similar when I'm trying to set up a web server that uses secure socket layers or secure HTTPS. Here's how it would work. Me, the administrator, I have to go to a certificate authority and get a certificate. And then I have to install that on my web server. And then when you use it, you go to the machine and say, hey man, I want to set up a secure HTTP connection. And it's going to digitally sign this thing and send it on back. And you'll know for sure that you are actually talking to the website you think you're talking to. Woohoo! And so one thing, it tells you tells you that you've identified who the person is, and you're using that very same key for encryption. So it's actually kind of cool. Hash functions. Hash functions are one-way things. I take a document that's got 5 million characters in it. Okay, 5 million bytes. And I crunch it down to a hash that's a 32-bit number. So it stores in 4 bytes. So 50 million bytes down to 4 bytes. Okay? So it's fairly obvious that this is not like a compression routine, right? I mean, there's no information in here that can get you back to your document. There's no way in hell a 4-byte number could possibly recreate a 50,000 byte document. That just ain't gonna happen. So hashes are one way, and the way it works is I create a hash in my end, and I tell you what the hash results are. You at your end, you just repeat the process and compare the hashes and go, yep, no one has messed with it. Ah, that's integrity, isn't it? Okay, good. OpenSSL is a tool for doing this stuff. For example, I want to install a certificate that I've gotten. So OpenSSL. And there's a gazillion of these options. I mean, I was stunned when I typed OpenSSL and got, boom. I mean, tons and tons of stuff about, how to set up. It's amazing. You could spend a week working on just this one command. Pretty good privacy is another technique for doing compression and authentication and all that kind of stuff. A lot of people like this one because they can be assured that there's no government or state-sponsored hanky-panky going on. But people who are paranoid that don't want a back door. Okay, remember how this example here where the person had to go to a certificate authority and prove who they were before they got a certificate, right? Well, if you're a drug dealer, you really don't want to do that, do you? You don't really want to give the certificate authority your real name, your real address, right? Because you're a drug dealer. So you need something else. You need something where you can go get a certificate without displaying who you are. As long as the other person trusts you, well, then you're okay. That's what pretty good privacy is all about. Kerberos is another system. Kerberos is a authentication kind of a scenario. Microsoft uses it inside Active Directory to how it identifies your login and password stuff. It's used internally. Okay, on page 1016, they talk about the secure shell. If I want to remote from one computer to another, so basically I want to, this thing is sort of like a terminal window. If I want to create a terminal window into another machine, I can use OpenSSH. Now, it kind of sounds like the same thing as OpenSSL, but only one letter different, but just bear with me. So it does remote login. In the old days, there was lots of other options. There was one called rlogin. There was one called telnet, but no, those are kind of gone now. Everyone just uses SSH. It includes, authentication. It has plugins for doing all sorts of encryption. Encryption. You can do host verification versus certificates. It's pretty powerful stuff. I'm going to skip a bunch of junk. And let's get down to firewalls on page 1027. So, the UNIX firewall is UFW. That's not very imaginative, but that's okay. So if I was to just type UNIX firewall, and then just say status, okay? Oh, dang it. Okay, inactive. Now, first of all, I think that's a little weird. Okay, I do. That the Linux folks installed the firewall but didn't turn it on. That's weird. Another one you can do is, remember I talked about IP tables? So there's one called, that's what it's called, IP tables. Dang, if I can spell. And I'm going to go ahead and give it the -L. And basically it's saying, I got nothing. Here's what I'll accept for the input. Here's what I'm going to forward. And here's what I'm going to do on the output. And they're blank. So, yes, you probably should do something about this in the real world. It's a little bit much for us to do in our class here, but I'm just telling you, you're kind of open. So packet filtering is what the firewall does for a living. The IP tables basically sets it up. And there's basically a rule, and the rule has a handful of parts. The rule has what is the source, the source IP, the destination IP, the protocol number, the port number, the direction, whether it's in or out, okay, and then enable or disable. So there's 6 parts to this thing. My address, the source address, destination address, protocol. And protocol typically is only TCP and UDP. There's practically nothing else. The port number that I'm using, like port 80 for the firewall, for the web. The direction, like incoming port 80. And then whether it's enabled or disabled. Now, if you want to get a list of all of the services, there's a cool little thing you can do. I just said, etc. services. This basically is a listing of all of the services that the machine kind of knows about. This doesn't mean they're turned on. It just means here's a list of services that it kind of sort of knows about. And if I keep going down to where 80 is, then you can kind of see the 80 is HTTP. Cool. All right, that kind of stuff. All right. So if you run across a port number and you go, what the heck is that? Well, you could consult this to find out what the heck that thing is. Okay. And the next one is stateful packet inspection. So what stateful packet inspection basically does is I want to filter incoming FTP requests. It's a file transfer protocol. But I want this thing to be read-only. So in other words, I'll allow you to pull documents from me, but I don't want you to be able to push documents to me. So it's like a read-only file transfer that I'm exposing to the entire internet. So I don't want to filter all FTP requests. What I need to be able to do is when an FTP request comes in, I need to stop and look inside the FTP request and see what kind of request is it. Is it a directory listing? I'll allow that to go through. Is it a copy? I'll allow that to go through. Is it a multi-copy? I'll allow that to go through. Is it a write? Ooh, I will not allow that to go through. So stateful packet inspection means I see a packet and I look inside the packet to decide whether I'm going to toss it or not. Kind of makes sense? Cool. Okay, we're coming up on the 15-minute mark as usual.